Hello YouTube, let's have a look at a bit more move generation. Specifically what I want to do today is to generate rook moves. Rook moves is a type of ray move, ray attack. So similar to the bishops here, we need to use the ray attacks, but obviously only the ones that are going north, east, west and south. But it will be quite similar. So let me skip over most of it. So here we are. Now we have generate rook moves, and on the right we have generate bishop moves. Now you may notice the implementations are very similar. So it may be beneficial to factor something out. For example, this macro would be nice to factor out. So right now it's using, let's see, two local variables. It's using new positions down here to push into, and it's using the attacks variable to index the what's it called, where to get the ray attacks. So I think we will do something like this. Rays, now we will think of rays as being instead attacks dot, for example, north rays. Then we can do this. And now we want to say, we also have to supply where we want to push things into. So let's say positions, and then we can write down here, instead of new positions, we can we can write positions like that. And let me see here. It's also referring to piece, which is a bit annoying. So we also need the piece, I think. We also need the game. So we're needing a lot of stuff now. Also an identifier. So it's not super nice, but once we have done this, we can move it out. Let's put it up here for now. And then we can say down here in the bishop moves, we can say, first of all, get rid of this one. Why don't I just delete it? And then we want to say the rays, which should now be attacks dot rays. Then we have forward again. Then we have new positions, and we actually want that for all of them. So we can do like this. Then we want, let me do something so I can like multi-line edit. Then we want to say piece and game. And now if I copy it down here, not sure what I did wrong there with my Emacs, but whatever. Then I should be able to say, okay, for the rooks we just want north, south, east and west. Okay, so I shouldn't have changed anything for the bishop move. So if I run the tests, okay, here we are. Then it complains, no rules expected, the token dot. Interesting. So maybe we just call this an expression. It won't complain. Okay, so we forgot to use this one. Own occupancy. Ah, damn it. Can we calculate that? Yes, I think we can. So, oops, we are just gonna grab that, put it in here. Then we also need position, but that's easy to get from the game. So we want to say reference to game.position. And the same here. The same here. Reference to game.position. All right. Now I think we're good in that regard. So let's see. 119. Not like that. Like this. Okay. So maybe we remove these references. Now line 100. Oh, okay, so this should not be positions. This should be new position. Great. And the tests are now passing. Amazing. So nice to have tests so that you can refactor without messing things up. Okay, now we just need to write tests for the rook moves. So I will also do that off screen since it's quite similar to the bishop moves. Okay, here we have our first test where we are putting a rook on the third rank on the 5th row. So I guess that's E3. And this makes me think that we should have a nicer interface for setting up positions. So it's a little bit more readable. I mean, after all this time, I'm kind of used to reading FEN strings, but it would be nice to have a different way to say that put a rook here, put a rook there, maybe some kind of builder pattern. But look at that another time. And here we have positions, which is generated from the new function. And again, I just specify the positions like this, like with raw numbers. It's a little bit difficult to understand. So let's also make a utility that will let us write this in a more readable format. But in any case, now we do the same as always. We assert that we have the correct number of positions, and we check that each position has a piece on the correct place. We could also, just because, why not, assert that the piece, the piece that we have, the piece type is actually a rook. It's also quite a good test to have that your rook doesn't turn into something else. Now we can repeat this a couple of times. Once for, let's say, one enemy piece, and once for one enemy friendly. But before we do that, let's first of all, don't really want to keep this anymore. Let's mark them as to do. Before we go much further, let's write this utility function that lets us say something like game is game. So we want to make like an empty game, and then we want to say add a rook at e3. You know, this is how we want to use it, and then we want to say also, instead of this down here where we have to think really hard about what the numbers are, we want to say get indices, get square indices, and then just give it a list like this. So for example, which squares can a rook hit from this? Well, it's quite easy in this notation. It's e1. Okay, but also it's quite annoying to have to write the colons all the time. So really I want to do something like this. e1, e2, e4, e5. But that requires a procedural macro, and that requires a different crate. Cannot be in the same crate as this one. So it's a little bit more advanced. It's not really what we want right now. It's a little bit more advanced than what we can do right now, I think. So therefore, let's say something like get row. Then we want to get the third row. We want to append or extend or something. Get column E. And then we want to remove e3. Because the rook should not be able to be where it started. So let's try to make that. It's obviously some, maybe not obviously, but could be utilities. So let's make this thing first. Now the game struct is in here, so we will do this. It is actually quite easy to do. We just return game, read FEN, and it will be 8, 8. Let me see, this is 4 rows. So if I copy that, do like this, then doesn't really make sense, this thing, but let's just, you know, it doesn't really make sense to say it's white's turn to move when there's nothing on the board, and we'll make it so there's no castling rights. So now we should actually have tests for that, but let's not do that right now. So the add function. So first of all, we need a mutable reference to self. We need also the piece type, and actually we need something like this. So we need the piece color, which I think I just called color, and we need piece type, and finally we need the square, which in this case will just be a string, and it will not return anything. It will just modify the struct, because it's kind of like a builder pattern. Let's see if it more or less compiles. It did compile. Great, let's format it. Then basically this should just dispatch to the position. same arguments. And we can copy this stuff, go to position, go to the implementation of position, go to the bottom of this huge class, struct data type, whatever you want to call it. And let's do this. We don't need to see the other thing for now. This is wrong. Let's put it to do. Let's check it. It works, or it compiles. So we haven't done anything horribly wrong yet. So let's start by turning this string into an index. So let's let the column be, first of all, maybe we should assert that it's a valid. A valid square. And then we can say square bytes the first one minus this one SU8 . Let's try that, and the row is probably this doesn't work. Yes. Okay. You cannot index into this thing. So let's do this. And now it's, for some reason now it's complaining in move generation. So it's saying you cannot, doesn't know about the white thing. Let's put this guy. Okay, I was was under the impression that you could do this. Let's check it. Can I index into a value of eta? Okay, so you cannot cast this to U8. Makes a lot of sense. Let's try to make it a character. That works. So let's ensure that this is the correct type. Is that nothing crazy is going on? So I'm basically looking at the first character in the square specification. So square could be E3, for example. So I'm getting E, and then I'm using the fact that that like A is some number in ASCII, it's like 63 or whatever, and B is 64, and so on. They're laid out consecutively. So instead, what I really want is A to be 0, B to be 1, and so on. So I can just subtract whatever value this is. I don't need to know what it is, so just subtract it. And then I get the correct number for the column. Do the same thing with the row. You know, should be 1 or whatever. You could also try to read this, but whatever. So then the index should be row times 8 plus column. And then we want to add a piece there. So let's make the piece. First of all, how does the piece look? Looks like this. Does it have a new function? Does not have a new function. So we'll just make it manually. So the position is this thing. The color is whatever the color supplied is, and the piece type is whatever is supplied. Then we basically want to say that, okay, let's add this piece. Let's put this thing at let's reference how's a square. Let's make sure the correct square references that piece, and then we are good. So the way it works right now is it overrides whatever is in the square, which is not great necessarily. If there is something in the square, then it will override it. No square will have a reference to it anymore. That means there will be something in the pieces list which is not referenced anymore, so it will kind of be like a memory leak. You know, for that reason, probably we should handle that case. And I am just going to do this. This doesn't work like that. If it is empty, then we do this. Cannot format. Everything is screwed up. Otherwise it's occupied, and then we want to say, we want to panic, and we want to say that this square is already occupied. So now we don't have to worry about that. Let's check it compiles. Does not compile, because we should cast this to usize. Great. So now we have a new couple of tests. Test make empty. So we will say, give me an empty position. Let's just comment this out for now, so we can actually run the tests. Did I not just implement this? Or am I going crazy? Right, so we don't have an empty here because why not? I'm going to add it here instead of on the game struct, just because it's a little bit more consistent, I think. So there we go, and this one should read should be this basically, but with an empty position instead. Let's run that. Okay, that worked. So now we make one that adds a piece to an empty square. Now we need to be mutable. And then we want to say, let's add a white rook to e3. And now we should have one piece. And the position of the piece, let's say, should be 24. I know it's 24 from before. It shouldn't be positions. And so we need piece type. We need to use that, because I cannot be bothered to write piece type : every time. Okay, it failed, and it failed because I forgot that this should be bitmap. That also failed. So let's see. E3 should be 6. No, sorry. So it should be 20. Okay. So looks like we can add another one, another quick test, where we say that it should panic. I think it's like this. And we will say cannot add to occupied square. That didn't work. I thought there was something like should panic. Okay, let me just, this is gonna give a lot, but okay, I'm gonna look it up. Okay, I realized the problem now. The problem is that when I run the tests for the local file, I've set it to also print all the output. That's why it's printing this, but actually the test runner is very happy. So if I just run this, then we should see that yeah, we have the 2 failing tests that we haven't implemented, but everything else should be okay. Exactly 2 failed. Okay, so whoops. So I think we are happy now. Let's go back to move generation. Okay, so we still have this outstanding thing. Not sure where to put it. I am going to put it up here, because this code so let's say square to index, and let's just return a, what should it be? Can just be this type, U64. So it's the same thing. You know what, let's say that it's a U size, and then we return row times 8 plus column as U size, and then we can just call it from here square to index, and let's kill that, and then we do code reuse. Amazing. 11 passed, 0 failed, great. And go back to move generation. Then I want to say new positions is okay, first of all I want to say that the game is empty and we add a white rook at e3. So I know the rook should hit e2, e1, it should hit a3, a1, no, a3 was correct, b3, c3. I'm going to write it in a slightly different way. c3, d3, e3 no, f3, g3, h3. Then it should also hit e4, e5, e6, e7, e8. And that should be it. Okay, format. Oops, forgot a comma here. Great. So, what have we done wrong now? Okay, so right, so the add function needs to return itself. So we get this builder pattern. Let's try that. Didn't like that. Okay, so I just looked up a little hint. It seems like what we need to do is say something like this. And then let's go back actually and look. So for example here, there's this builder pattern where you say name is something. And what it's doing is mutable self. It's returning its own type. And then you just say self at the end. Let's try that in here. It compiled and worked, so that's great. And so then we have this position things that I actually don't want to just be these strings, but I want to map the string into this function that we just defined, square to index, give it the string, and then I want to collect that into a vector of usize. Let's try to run that. It worked. Let's format it. Let's remove that. And is it still working? Should say test generate rook moves is okay. Okay, so I think, except for the fact that it doesn't, the formatter doesn't automatically like it's okay with this huge line. It's a little bit annoying maybe. And it's a little bit annoying to have to put these colons, but we will make a procedural macro for that another time. I just don't want to get into that right now. Okay. Now we can say, again, we make an empty one. We Also, I don't want to write color. So let's use all of those. Oh, not my intention. So let's add a white rook at e3 again, why not? Then we also add, not like that, we add a white rook at e5. No, we want to add a black rook because of the test name. Then we expect the new positions to be e1, e2, e4, e5, a3, b3, c3, d3, f3, g3, h3. Then we put some nice colons around it. Get it to format. We iterate, map, the square to index. We collect. I wonder if you could do without the collect. I'm just gonna try that now. Okay, for some reason the formatting is messing up a little bit. Then we do the usual thing. Now we want to assert either this or this. And how was it we did this? It's probably always going to be the first piece. So this is fine. Actually, something we could do is also just make sure it doesn't change color. And I'm happy with that. Let's run it. Square to string also, it's not what it's called. It's called square to index. It didn't like that because we never actually generated the moves. Now it doesn't have a field called piece color. Fine, it's just called color then. And alright, so we actually have to collect because there's no contains for this map type. Alright, run it, test, generate, run, rook moves one enemy. It failed, so it's very interesting. Does it say where it failed? It says it failed at line 359, so it failed here, and it has 3 more positions. So let's actually print these positions, and we want to print them in a nice way, so we want to iterate and map the position, and we want to get the first piece position, which is then just the bitmap. So we want to bit scan it, and then we want to actually turn it into a string. I'm just going to do it like this. Then we'll collect it, and it is collected. Now if we run it, it didn't. And also, why am I writing print function? Should be print length. And again, it's not use size. I'm a little bit tired, I think, now. So let's look at the positions. So there's something wrong with the blocking for sure. Unless Unless there's something wrong here. No. Okay. Let's just, for the hell of it, bitport to string. Actually, didn't I have the print bitport? And I want to print the game, don't mark any squares, and it's not imported. Now it's imported. It didn't like that because it's printing it should print a bitboard. Okay. Game.position.white occupancy. Let's just do this for now. Okay, black occupancy. Okay, so this is very interesting. It's like the game thinks it's empty, but there are pieces in here, so that means we have a bug, which is that we need to calculate the occupancy, or let's say recalculate. So we should have a test. Let's make a test. Test add as correct occupancy. We want to do this, and we want to first of all assert. Can you assert not equal position dot white occupancy is not 0. Position dot black occupancy is 0, and it's a little bit silly. Let's just assert that it's equal to this. If I now go up to the add function, then run these tests, we get a failure because the occupancy is not calculated correctly. Okay, we panic if there's something there, so we can safely assume there's nothing there, at least at this point. So let's match the piece color, and if it's white, then we want to say that the white occupancy is the same, but we add another piece, and the same for this one. So it should be black occupancy. Then we're good to go. Should pass. It passes. We go back here. We run this. Okay, so it now seems correct. And we also get a success here. Okay. So can this mini buffer go away? Thanks. It makes me wonder if there's anything else we forgot. So maybe you could write a function that like checks if everything is consistent. So if we add a piece, should surely affect pieces. Should also affect squares because that's references from the square index to piece. It shouldn't affect color or castling rights on Pesang hyperclocks, all this metadata about the position, because that, like we're imagining using this as an easy way to set up a position, but it should affect these two. So now by going through all the fields, I think we can conclude that the implementation is more or less correct. Could write more tests. You can always write more tests. But we won't do that now. So let's make a game, an empty game. We want a friendly piece on, let's put it somewhere else. Let's put it on D5. we want another friendly piece. Oh, yes, whatever. Let's put it on D2. Then we want the enemy piece on G5. Okay. The new positions that we want to assert against should be D1, D2, let's say, yeah, this is the one that we want to move. So actually we cannot hit D1, but we can hit D3, D4, D5, no, D6, D7, D8, then also A5, B5, C5, D5, E5, F5, G5, yes, but not H5. Okay. Maybe I should get some kind of multi-cursor package so it would be a little bit nicer. And now we are writing this pattern again, indicating it should be a function, but I won't do that right now. Because I think this will be the last function. Just rewrite for now. So now we have the positions, or the expected positions. Now we want the new positions, which should be generate rook moves, and we say game.position.piece is the first one. Give it the game. Then we do this thing again. Let's run that. Also, it's still printing something, which is this thing. I don't want to print that. Okay. And it failed and not yet implemented, which is good. Now, I think I can still assume that it's the first piece. That looks correct to me. Let's try it. Okay. Great. There was one case. There was the one case where we had to do some crazy things like this to check there was a white piece on the correct square, and that was because we didn't control the order of the pieces. When we just read in a fence string, it's just whatever order it gets it in from the fence string. But now, because we have this builder pattern, we can always say I begin by adding the one I'm interested in, and then I add the pieces that will, test that blocking is correct. And that way the test code becomes a lot simpler, because we know that the one we're moving is always the first piece. So I kind of like that. Now I should rewrite these tests up here. But I don't really want to. I'm gonna leave it for now. Now, next time we will look at queen moves, because now we have rook moves, we have bishop moves. It makes sense to then make queen moves. Queen is a rook plus a bishop after all. Okay, until next time.